Hi class, here's today's video on solving quadratic equations, putting together all the methods we learned. Here's your first question to think about. In Enriched class, you'll get started on word problems. Everyone else, we will do word problems tomorrow. Here's your 5 practice problems using the appropriate method. For the Enriched practice, you get some bonus word problems, 2 days worth of practice. Here are your first 3 word problems. And here's your last one. Let's get started. So for the first question, as we learned a bunch of different methods for solving quadratics, let's talk about the disadvantages of each. So graphing, only useful when given a graph. Even then so, it's not precise. Lots of work to do by hand. Some of the benefits of graphing, you get to see the shape, you know clearly where the vertex is, and if it all happens to be on the grid lines, then using a graph is handy. Next one, we have factoring. Doesn't always work. Because factors can't be determined. And if you have large numbers, factoring may be possible, but it'll take a lot of time. Completing the square, new, so disadvantages, it's complicated. At least some of you may think so. What I mean by complicated, lots of steps. And some drawbacks that you may not have noticed the last week when practicing completing the square is that b has to be even. When b's odd, you'll deal with a lot of decimals or deal with 0.5, and that becomes a pain later on, but it's definitely possible, but it's nice, so that b being even. Some of the benefits of completing the square, it always works, along with the quadratic formula. But the other methods of factoring, graphing may be easier depending on what you're given. And you may have different thoughts on these different methods of solving quadratics. Some may be harder for you, some may be easier for you. Take some time and think through this question. We'll get started with the practice. You may at first be intimidated. You see a bunch of fractions. You can make them go away. Multiply by 5. That is for the whole equation, so that looks like 5. I'd like to put it in brackets. Like so. Okay. So then your equation becomes something a bit more manageable. Oh. Let's multiply by 25 instead. I want everything to go away. So then this becomes 25y. This becomes 75 over 5. This becomes 25 times 2 over 25, which equals 0. Cancel this. So it becomes 25y 75 divided by 5 is 25 y plus 1. I misspoke. I'm getting 15y equals 0. At this point, you gotta make a choice. You could use the quadratic formula, that always works. You could complete the square. You can think about the box and the diamond. And in this case, it does end up working. As you multiply these two, makes 50. So then what two numbers working multiply to 50 but add up to negative 15, negative 10, and negative 5? Factor. Factoring works. Factor it. So then you have, let's see, might as well draw out the box and the diamond. Okay, this one was multiplied to 50y squared. Add up to this, negative 10y, negative 5y, put it all in, 25y, 2, 10y, don't forget the negative, negative 5y, 5. 1, 5, 5, 2, negative, negative. There we go. You have 5y minus 2. 5y minus 1 equals 0. By 0 product property, 5y minus 2 equals 0 gives you the answer of 2/5. By 0 product property once again, this gives you an answer of 1/5. Okay. But you could have used the quadratic formula even from the very beginning if you had a calculator. At this point, you could complete the square too. Actually, complete the square is not a good idea. This is not even. Okay. Reminder of factoring. Here's the next equation. Maybe we'll use the quadratic formula for this one. You can get rid of this. But that doesn't matter as much. You could leave it in. So a reminder on how to use the quadratic formula. This also ends up being factorable. As a reminder for the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. Here's your a value. A here equals 2. B here, don't forget to take the sign with it. B is negative 8. C is 15 over 2. So negative of a negative 8 plus or minus square root negative 8 squared minus 4 times 2 times 15 over 2 all over 2 times 2. So I'll simplify these three parts. Negative, or the opposite of negative 8, gives you positive 8. Inside the square root, we have 64 minus, these go away. So that gives you a total of 60 divided by 4. Simplifying it further, see that we're left with square root of 4, which gives you 8 plus or minus 2 all over 4. Your two answers, here's a plus, here's a minus. 8 plus 2 over 4 8 minus 2 over 4, 10 over 4, 5 over 2 is one answer, and 3 over 2 is one answer. Let's say you didn't want to use the quadratic formula, alternate method. You can multiply the entire equation by 2. Then factor. So you can try that out. Gosh, wires are crossing in my head. By 2. Okay, you can factor that. Well, that's an alternative way, and you'll end up at the same answer. Maybe for this method, we can show off completing the square, just as a reminder of how to do it. We could also factor it too. So I will write tinier. Let's see if I can do this. On this side, let us try to factor. Okay. On this side, we'll complete the square. So we're going to multiply everything by 16. So we have 16x squared minus 16x plus 3 equals 0. Draw your box. Draw your diamond. 16x squared, 3. Together that makes 48x squared. Try to add up to 16x. We think, 48, 16 and 3, 13 and 3, what are they? 12 and 4, there we go. And 4, 4x, negative 1, negative 3. So factored gives us this form, so 3. By 0 product property. 4x minus 3 equals 0 gives us x is equal to 3/4. There's one answer. 4x minus 1 equals 0 gives us an answer of 1 over 4. And just for practice sake, let's complete the square from here using this equation. We think about what our b term is. Let's rewrite it first. B here is equal to negative 16. B over 2 equals 8, negative 8. B over 2 squared is positive 16. So we think about 16x squared minus 16x plus 16. Let's see. Oops. So plus something, but we're already at 3. So we have to add on another 13 here. So then our whole equation now becomes 16 times x. Well, let me write it out step by step. 16x squared minus 16x plus 16 equals 13. Factor out the 16 like so. We see that we have the perfect square in there. 16x minus 1 squared equals 13. We go ahead and solve this. You can see it getting complicated. I feel like I made a mistake somewhere. 13 to both sides. Yeah, that looks right. 13 over 16. X minus 1 equals the square root of 13 over 16. Plus or minus. Not seeing how this turns up being the same. Did I make a mistake somewhere? Oh well. Plus minus positive 13 over 16 plus 1 negative 13 over 16 plus 1. I think I made a mistake because I'm not seeing the 1/4. Huh. Looks like I'll have to come back to that one with completing the square. It's often that now that you know the quadratic formula, you probably won't be doing it. I'll probably post on Piazza on what my mistake is after I have some time to think about it. For these next two, if you have a calculator, you could go ahead and use the quadratic formula from here. When you see decimals, you can multiply everything by 10. So you have now 2x minus 7x minus 60. 0 times 10 is 0. And this, do we want to factor? 10 and 12, 60. Yeah, this is what I was talking about with larger numbers. You have to think about the factors of 120 to make 7. It's a little bit harder. 15 and 8. Does that work? 15 and 8. Okay, could factor. Maybe I'll just get started with this one. Negative 120. Negative 120. I think 15 and 8 may work. Negative 15 x 8x. Yeah, so there's your hint for factoring. 15 and 8 do end up working. We could use quadratic formula. Just as a refresher again on how to use it. Negative b plus or minus square root b squared minus 4ac all over 2a. Negative of negative 7 square root negative 7 squared minus 4 times 2 times negative 60 all over 2 times 2. Let's simplify. Positive 7 on the outside, 49 plus 480 all over 4. 7 plus or minus the square root of 5. What? 9 all 29 over 4. Gosh. I don't have that memorized. If you want to, you do. 529, 23. Okay. So let's keep going. 7 plus or minus 23 over 4. Think about our two answers. 7 plus 23 over 4. 30 over 4. 15 over 2. 7.5. That's one answer. 7 minus 23 divided by 4 gives us negative 16 over 4, which gives us an answer of negative 4. Okay, last example for the fundamental section. Another equation. You see decimals, you could leave them in if you have a calculator handy, or you can multiply it all out, your choice. We can multiply everything by 10. To get rid of the decimal, we get 50x squared minus 5x minus 3 equals 0. Negative 3 plus or minus squared minus 4ac all over 2a. You can get pretty far just using the quadratic formula. Completing the square, although nice to have, is not required. Negative of negative 5 plus or minus negative 5 squared minus 4 times 5 times negative 3 all over 2 times 50. Positive 5's on the outside. 25 minus 200 plus 600 all over 100. 5 plus or minus the square root of 625. I think that's 15. That's 25 squared. All over 100. Here's your two answers, minus and plus. Plus 25 all over 100. 5 minus 25 all over 100. 30 over 100. 3 over 10. 0.3. Here we have negative 23 over 100. That gives us negative 0.23. We can always turn it back into a decimal that way. Can we factor this? Let's think. Set up your diamond. Negative 150x, adding up to 5. 5 and 10? Yeah. So you could factor this too. 15 and 10 could factor. Your choice. This is the end of the fundamental section. The rest will be working on word problems for those that choose to do the enriched part of today's lesson. We'll get more practice with word problems tomorrow. Here we have a square that we're thinking about, reminding ourselves perimeter and area. So if you have a square that has side length s, the area, also known as s squared, is going to be called a. The perimeter, since it's a square, all this is s, is 4s. Call that p. We're trying to show that the area equals this thing. But right now we have it written in terms of s. So let's term that s is equal to p over 4. So then it's s squared. Using this substitution, p over 4 squared equals p squared over 16. So that all equals a. Done. Kinda handy. We have to make use of these area and volume relationships in our next couple word problems, like in this one. They end up being quadratic, surprise, surprise. You have a rectangle. It's nice to start with a diagram. Call this length, call this width. Length times width is 63, so that is the area. Length plus width plus length plus width, that's the perimeter, equals 32. We can simplify this. 2L plus 2W equals 32. And in this case, it's going to be handy to factor, and you'll see why. We can factor out the 2 to give us this equation here and this equation here. Now we have two equations with two unknowns that I'll rewrite over here. So we can solve, but we're going to have to use some handy substitution. So we're going to transform this equation, divide both sides by 2 to get this. Solve for either L or W. In this case, let's solve for L equals 16 minus W. And from here, you can sub it back into here. So then that will bring us to 16 minus W times W equals 63. That's a quadratic you know how to solve. Let's make it a bit more obvious. 16W minus W squared equals 63. Transform that once more. W squared minus 16W equals 63 equals 0. So from here you can solve. Look at this equation. I see that it can be factored into something looks like this. So, oops, I changed to x. It's W in this case because I'm solving for width. And from here, 7 or 9 centimeters. This does make sense. If your width is 7, that means your length is 9. If your width is 9, that means your length is 7. So both answers make sense in this case. We got the dimensions. Similar practice down here. 42 and 26. So we can use the same setup as before. Notice the structure of the word problem is the same. So then we get L is equal to 13 minus W. Again with the substitution. 13 minus W. Oh, let's try this. Why don't we solve for the other one this time to see that it works? Let's solve for W. Oops. $13 minus L. 13 minus L, oops, times L equals 42. 13L minus L squared equals 42. L squared minus 13L plus 42 equals 0. We have some options. We could use the quadratic formula, we could factor, we could complete the square. When I look at this, I see that you can factor it. L minus 7, L minus 6. Equals 0. L equals 7 cm or 6 cm. Again, just like before, this makes sense. These are your dimensions, your length, and your width. When the length is 7, your width is 6. When your length is 6, your width is 7. A little bit more complicated problem. In your number 5, we have a box that is formed by cutting the corners off of the square. You'll see these problems, similar ones, later on in Algebra 2. Maybe in geometry if you're in there now. Okay. So we have our corners that are like that. We fold up our box so it looks like this. Once you fold it up, okay. Length times width times height equals volume. That's something you'll need because we know that this equals power 76 inches squared. Cubed. Squared? Cubed. My bad. You know your height from this picture. 4 is the height. Length times width times 4 equals 576. Then you're thinking, okay, I need another equation. One equation with two unknowns over here is not good enough. So we think to ourselves, what's my other equation? Because that's a square, length equals width. So W times 4 equals 256. Now we have one equation with one unknown, only one variable, so we can solve for it now. But be careful. You can't stop here, but wait. We have to account, because right now this is like everything chopped up. It's interested in the original square. So when we account for the pieces that were cut away, because W was the original width, okay, we have to take away, if you notice, if this thing was your width, we have to account for those four things, right? Same thing on this side. If this was W, we have to account for these two things that were chopped off. So that's where the -8 comes from. Okay, let me continue my work on the left. So W minus 8 squared times 4 equals 576. W minus 8 squared equals 576 over 4, which is 144, convenient. W minus 8 equals square root of 144. W minus 8 equals 12. W here equals 20 inches. And we're done. That's today's lesson. Work on your assignments. Don't forget to do your exit tickets and check-ins.